Hello. Oh, hello. Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hi, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 104. Today we're talking about Delicious AI, a DVD scanning microscope, and battery-friendly microcontroller designs. Elliot, I've got no news this week.
That's okay. I got news for both of us.
Oh, what do you have?
I don't really. I've been working on a small project with and for my son. We picked up a 6-pack of returned remote control cars with the hope that we could cobble a couple of them together and make them work. And it turns out that like 4 of the 6 actually just worked out of the box with like super minor repairs to them. And so then we had these other ones. And the reason we bought them is because they have those Mecanum wheels, the ones that can drive sideways as well.
Yeah.
And it's really cool, except the remote control for this thing is all like full on, full off. So it can go forward, backward, turn, around its axis, like perfectly turn, like on a pivot, and also go strafing crabwise left and right, which is pretty awesome. But I'm like, I bet there's more here. And so I took the controller apart and man, it's a single-sided board. This is the lowest quality, the lowest cost Chinese remote control. It's a single-sided board, and it's got these like heinous 8-pin dip H bridges. And all I had to do was desolder them with a little soldering wick, pull the pins up, and solder on my own microcontroller to run the thing. And it's super fun. What can I say? It's not done yet. I put an ESP32 on there because the ESP32 has these really great LED PWM units and 8 of them. And so I have four motors times 2 directions is 8 PWMs necessary, given the way this thing was built anyway. And it's awesome. I can make it do like blends between turning and crabbing, and it can move in directions that you can't even describe. It can drive sideways at 30 degrees forwards. Like, it's crazy.
Well, electrically, there's really not another way to do it, right? I mean, it's an H bridge. There isn't like a more advanced driver you can be. It's just that the controller wasn't using the pulse width modulation, right?
Yeah, the controller just wasn't doing anything smart at all. It just slams the H bridge. Mm-hmm. Each one of the 4 H bridges full forward or full backward.
Did you have to get a new remote for it then?
It doesn't have a remote anymore. It's an ESP32, so it's over the web.
That's even
it's a
better.
Wi-Fi remote, and
yeah.
Actually, at the moment, it's self-controlled because I've been playing around with MicroPython on the ESP32, and that is fantastic. So it's actually got a MicroPython on it, and I can telnet into it and start coding on the little rover as it drives around, which is dangerous, fun, and exciting.
I should try that out. I did a little MicroPython on the cardio badge from CCC Camp in 2019. I must have put it on the 1-bitsy and played around with it a little bit, but I haven't really done anything beyond those 2. So this is interesting. Certainly, you need another ESP32 inside the body of a joystick to be the controller for this.
Right? I mean, I think this one's going to end up being the base for an autonomous robot rather than a car.
Oh, okay.
The ability to like pivot on the spot and drive sideways and stuff is really awesome. And my first project actually is to hook up a logo-like language for it and probably directly host it on it and have Max learn to do logo by driving it around.
Can you do Bluetooth with the MicroPython?
A with the MicroPython and B with the ESP32. So
cool.
Yeah,
well,
totally.
I got a couple modules sitting in front of me. Maybe I'll give it a try as well.
So let's talk about some other people's hacks. First up this week is a hacky hack. Nissan gives up root shell thanks to hacked USB drive. This is a marvelous little hack and a marvelous write-up of it by EA. You should go check out his GitHub if you haven't. The car in question is a Nissan Xterra, which has a little bit of a touchscreen and smart device built in. I think this also applies for a bunch of other Nissans of that late 20 teens vintage. So if you've got one, this may work for you. Basically, what he's pulled off is a completely easy to replicate routing of the ICN2KAI head unit on this thing. So it's the big central console. And it's a really great tale of how you would reverse engineer something like this, how you would break into it, and then how you would make a hack that's simple enough that anyone could do it on their own without particularly any knowledge. And what you get at the end is everything runs just exactly as it did before, because the software on this thing is a Linux operating system, except now you have root on it and it's opened up an SSH shell for you. It's like jailbreaking your car, right? And he has a great demo application where he implements a GPS logger that uses the car's own built-in GPS unit and like logs where he goes. He's added a little USB to Ethernet dongle so you can get all this data in and out over Ethernet to your laptop in the car. And it's just a really sweet hack. I want to talk about how he did it later, but do you want to say anything about it? I have to log back into Google because it's that time of day again. Mother.
Elliot and I always talk about getting logged out of our accounts. Like the WordPress is locked to 2 weeks, so every other Monday morning you get logged out while you're working. And then yesterday while I was working, I got logged out of Google as well. So I don't know if that's like a 3-week thing, but it seems to always be Tuesday after lunch that I get logged out of that. So I liked this one for the USB to Ethernet dongle. I thought that was really cool. And it seems pretty obvious that the developers were using that as a way to access into it because it's kind of built into the kernel. I'm discovering that was interesting. But going right back to it, I think that those developers kind of left the door open on purpose. If someone wanted to, do some of their own Linuxing on this, I mean, really, what's the harm, right? So it is.
Oh, absolutely not.
No, you don't think so?
No, absolutely not.
Well, they didn't put a root password in place, and they allowed the system to not need one, and that saved a ton of time. So once he got in, and it uses U-boot, and once he got into the U-boot settings, he put a shell at the end of it, so it'll launch a shell up, and then you can go and cat out the password file and see, what ports are open and that sort of thing.
No, it's absolutely not intended. I mean, I think that would amount to gross negligence if they did. I think they really couldn't have possibly. I mean, this was the week in which Tesla got 135 Model X's recalled because their console went black, right? Like, this is security relevant.
It's not just infotainment?
Well, I don't know on this car if it's just infotainment. It's definitely...
this is still like the 2 DIN.
Yeah, but look, the AC controls aren't on it, so it doesn't do that. So it may just be like the GPS and...
It's a 2 tall, I think they're called DINs, right? It's a 2 DIN tall head unit form factor, which I think cars are going away from. It's hard to tell because like looking at the dashboards these days, they're all like crazy different shapes. But I mean, it's very different from, like you don't get an aftermarket radio in your Tesla.
Right. But to get into this thing, I guess we should talk a tiny bit about the hack too, because it's a great write-up. To get into it, he tries to attach USB devices to it and uses the face dancer to pretend to be a bazillion different USB devices and see which ones of them are accepted. And he comes up with exactly this one USB Ethernet dongle. But that's not a keyboard, right? The thing doesn't connect to any keyboards straight up. So there's no easy way in. So what he ends up doing is what you always should do if you're going to start hacking on your car, which is he goes to eBay and he buys the part rather than pulling it out of his car. Because pulling the center console out of your car leaves you with a big gaping hole, whereas you can pick one up from, the junkyard / eBay for not much money. This is a trick actually I learned first from Felix Domke, when he did his hacking on the VW ECUs as part of his investigation into Dieselgate. And we have a great write-up of his talk there. That is a must-watch. I'll throw the links in. Once he doesn't pull the unit out of the car and instead buys a new head unit over eBay, he finds a serial port on it, and this was another sweet little takeaway. When I try to get into serial ports like this, if it's got no delay on the boot thing, you can try to hit the enter key as fast as you can to get in there in that no second delay so that you can then type in your own custom boot line. His smart take here is to just cat continuously to the serial line from another computer so that as soon as it gets in there, it stops the prompt and it doesn't boot up. And that's the whole hack here, basically. He gets console on it.
Yeah.
He's got root. The super clever bit is making sure that you can do it by just sticking a USB drive in there. Because USB is the only surface attached here, he goes looking around in the UDEV scripts and he finds out that it will mount the pen drive that you stick in by using its name as the volume location where it mounts it. And so he sees that this thing normally boots up and fires off a logging script in user bin. And so he renames his pen drive to user bin. And you have to blank one of the other IDs. Anyway, the point is you stick this in there and the poor little thing
Get so confused.
the poor little thing, yeah, right? The poor little thing decides that your thumb drive is the user bin directory. So all you have to do is craft your own file in, call it logger, and open up SSH. And that's what he does. And so that means that for you, if you own one of these cars, this is a quick download, write it onto the pen drive, stick it in, turn the car off, and then you pull it off. And if there's a file that says it works on your thumb drive, you have root on your Nissan car. It's just a sweet hack. It's a nice overview of how you always go about attacking Linux boxes. And it's nice to see that you can kind of gain functionality in your car by doing this sort of thing, because he's required to have an app on his phone to get certain features out of the console of this car. That's just dumb. It's eventually going to be non-supported. You're not going to be able to do it. And so this liberates that whole darn thing. This is my hack of the week.
Yeah, it's weird. I mean, we talked at the top of this one about the threat of letting people into these infotainment centers, but I think that the functioning of the vehicle should be kept completely separate from the infotainment part of it. But maybe I'm just old-fashioned like that, Elliot.
Oh, I think that's a pipe dream. I think that's a ship what has sailed. If you look at a lot of the car hacks, they will discover that the infotainment's on the same main CAN bus as the system relevant stuff. And you can always jump from one bus to the other. Even though they should be engineered so that you can't, you can always find a way. And that's where it gets to be into dangerous hacking rather than just fun hacking.
Yeah, why do my windows go up and down when I press forward and reverse on the CD player?
Exactly.
All right, let's move on to the next one. This is an awesome piece of lab equipment that is inexpensive and easy to build. It's a DVD optics powered the scanning laser microscope. Gaudi Labs has built a few different things that are good for citizen science, including a polymerase chain reactor, the PCR, pocket-sized thermocycler for one that we looked at. Let's see, that must have been back at the beginning of last year. This time around, it is, I mean, think of the pictures that you get from a scanning electron microscope. This is a scanning laser microscope, and depending on what type of head you use for it, you can get down pretty small. In this case, it looks like a DVD laser head has been used, and it's going to have a resolution somewhere around 400 nanometers, which is just incredible. It has an XY on it, so two different DVD position sleds have been used for this. One of them is actually moving the sample, and that's like the line. So it'll put the sample at one rate. The other sled will scan in the X direction, getting the pixels from that line. And once all those pixels are in, then the sled will move, and it'll do another scan like that. But what's coming out of this, once they're put together in software, look just amazing. There are pictures going down to the dies on your silicon devices, and I can just think of all kinds of fun that can be had with one like this.
Yeah, there's pictures of yeast cells. There's pictures of, I mean, of course they can do the pits on a CD-ROM because, well, it's a CD-ROM reader. I thought that was actually really neat to see blown up as if it were a microscope, how kind of irregular some of the holes that are photolithed into a CD are. Must be a really tricky system to decode these. It kind of makes me worry a little bit. Yeah, this is just a beautiful piece of open citizen science-y type stuff, and I actually met 3 or 4 people from Gaudi Labs. They're kind of makerspace, hackerspace, bio hackers. Met them at Make Munich a few years ago. Really great folks. They had a bunch of crazy and awesome ideas about ways to make what are kind of high-end lab equipment available to hackers.
I was interested in more info on this. I had trouble finding everything that I was looking for because they do mention that they've taken the photo receptor out and replaced it with a photodiode, which is
Okay.
all that you need, which is interesting. I didn't really understand much about that. But they do link to a page where they're showing a bunch of the mods that they do with equipment. And I just loved this quote in there. The PHR-803T is a masterpiece of engineering manufactured by Toshiba, and this is the DVD head that they
Yeah.
used in it. So you get to see a little teardown of it, and it's just another example of how the economies of scale take what is like a wonder of hardware and make it just dirt cheap and available everywhere.
I bought actually a bunch of PHR units ages ago because back in the day, they used to have a really good 405 nanometer laser diode in them. And so, among other things, you can scavenge out of a PHR head. And they were selling for like $5 on eBay. Among the other things you can scavenge out of them is like I've forgotten how much it was, 100 milliwatt or something, ultraviolet laser. And I end up using that in some art projects and stuff. But then at the time, man, we have these hacks going back. I'm sure that someone else had done using the focusing system on these, because what's really neat about them is that they have to be able to focus really exactly on the surface of this DVD. And so they've got a tiny little linear motor in it, essentially, that raises and lowers that focal lens. And it's eminently hackable. I'll go dig up some links. My next hack is Youngster's ESP32 jukebox uses RFID to cue tunes. Martin Herholzer has made the Laura box for his daughter Laura, presumably. It's a music player for small kids, and he has little figurines that have an RFID chip in the bottom of them. You put them on top of this box, and then it plays music for you, or at least that's the kids' view of it. My view of it is that a hacker took all of these great little easily available modules, combined them all together, and with an I2S DAC and an amplifier chip and some really nice design, and I guess no small amount of software, built an incredibly pleasant and easy to use and professional looking device. And what I really liked about this design is that it's meant to be used and not recharged all the time. You might say to yourself, why did he use an ESP32? Why not a Raspberry Pi? And the answer there is exactly the power consumption. Because like a Raspberry Pi is using, 300 to 500 milliamps, and an ESP32, on the other hand, when it's running, especially if it has Wi-Fi disabled, is just using a few milliamps, and it can go into a sleep mode where it's using, 10, 100 microamps or something. Some really clever power design went into this that enables him to keep it running for, something like a standby time of 100 or 200 days or so by just paying attention to making sure the ESP32 goes to sleep. He found out that the I2S DAC was consuming a lot of quiescent power, so he actually shuts that down by a pin in the ESP32 when it goes to sleep. Of all things, the RFID reader barely consumes any juice when it's active, so he can use that to wake up the ESP32 with no problems, except, of course, it had an LED on it. And so he pulled the LED off of the RFID reader and, problem solved. Anyway, what I really love about this is that he paid attention to all of these little details and put it all together with I guess it must be a home routed, a home
Routed.
PC, a home milled PCB, all done by himself, complete with fingerprints on the copper. There's attention to detail all through, like, he keeps the analog side and the digital side far enough apart that you don't get horrible, funny background noises from the ESP or from the RFID reader. There's just a bunch of attention to detail here that makes this thing really slick and makes it hopefully so that he never has to open up this really nice wooden box that he put it in.
Yeah, I recently made something like this and I went the easier route. I think that this is kind of the learning, like giving myself a challenge route, because
Yeah, right?
you have to build out everything from the I squared S pins out to the speakers themselves. I started with an orange Pi board because it had the headphone port on it and I already had a pair of powered speakers. But if you're going to take that down to the microcontroller level, it's like every bit of it from the hardware through the software is going to be a lot more work. And I think getting it to the point where it's behaving exactly what he likes on this is really awesome. I am surprised that it would be a low power consumption, because I would think that while playing music, there'd be kind of a big drain because it's driving those speakers.
Yeah, but if you think about how something like a Bluetooth speaker runs on a lithium battery these days, it can
Yeah,
go for
you're
a
right.
few hours. And he's got two 18650s in parallel inside the thing. So it's got, whatever that is, 2200 times 2 milliamp hours. It's got a fair amount of battery inside it. So even when it's running, I bet it runs for 10 hours, 15 hours. I mean, how loud does a 2-year-old need to rock out anyway?
I think that that's a really good point on the Bluetooth speaker. Boy, that would be a great donor area for a lot of the stuff that went into this.
Yeah, what's really cool about this though is that it doesn't use the Wi-Fi or the Bluetooth. I guess Bluetooth isn't such a power hog as Wi-Fi is. This doesn't use the Wi-Fi very often. It actually just calls up a server that he has set up in his house, sees if there's new music to download, and then downloads it to a local SD card like once a day, twice a day. I mean, not very frequently. And that's a clever design choice too, because that means you can have it shut the Wi-Fi modem on the ESP32 off almost all the time, like except when it's pinging this web page. And that means that the ESP is basically just being used as a microcontroller, and it's not got particularly high power draw at all.
I have to admit, I do like the concept of trackballs, but I haven't really used them much in my life just because the options are not great out there. But I look at something like this particular project, which is a trackball with really nothing else that you need. You
Yeah.
just need the orb itself. So you could roll this thing around on your desk and it will act just like a trackball mouse. But of course, it's a little bit smarter than that. And Jacek has used some 2.5 millimeter zirconium oxide ball bearings in a 3D printed frame for this. It's the size of a tennis ball, and it looks like it works great. I mean, he shows it off on screen and it has very low latency. Inside of this thing, if you crack it open, it has a little Adafruit board. It is the NRF 52840 cents. And that sense means that it has a really high performance IMU on it, which senses all of your different directions. I looked up the data sheet for this, and it's actually a low power draw. When it's in high performance mode, it draws 1.25 milliamps, which is fantastic. I think it's Bluetooth low energy. It uses Bluetooth to transmit out to your computer. And also, of course, inside the orb is a 500 milliamp hour battery. In keeping with the all-in-one nature of it, there isn't a way to open the thing. It's like sealed shut. And so when you want to charge it, there's a wireless charger built into that 3D printed base of the thing. And then there also is a magnet in order to trip two different reed switches inside the orb. One of them kills the power, or it drops the enable pin so that the board puts itself to sleep. The other one is a calibration for up. So you can tell the ball which side is up and kind of get everything back to center again.
I use a trackball as my daily driver, but mine's wired and pathetic. I just love the feel of them, though. I won't lie to you, and this really speaks to me. I totally want to try this thing out. I'm a little bit wary of the IMU solution because over like long time periods, and especially if you're kind of jerky with it, IMUs have trouble, keeping up. There's some kind of integration error in the gyros that'll eventually add up and it'll end up drifting a little bit. And I don't know if that's going to be a problem or not, but then you see that he does have this way to reset it to zero, to reset it to fully straight up. And also, if you think about it, when it's not moving, it doesn't have to know its absolute orientation at all. It only has to know that it's rotating right now and then send that command across USB to your computer. So I'm not even 100% sure if the orientation sensing bit is necessary, but it's really
Yeah,
cool.
it's change, right? How do you get it back to the center of the screen? I guess you just
You just
keep
roll
twisting in that
back.
direction until it's there.
Yeah, I
Yeah,
mean, the same part of my trackball isn't pointing up when my mouse is in the center of the screen ever,
right.
I think. I mean,
Yeah, I guess what you have to ask yourself is there a benefit here compared to like putting an optical mouse sensor in a base and just using a dumb ball?
you can hold the ball in your hand and you can run around the
Ooh.
room twisting it in the air. Like, this is the craziest, most awesomest thing I've ever seen. Does he use the accelerometers in it to do tapping? Because you could do single and
No.
double taps on the ball
Right.
itself, right?
Yeah, no, he's got a cool split keyboard for it, and there are buttons for his thumbs. And so your thumb is going to end up being the mouse click buttons.
Oh, boo. I want to be able to tap on the ball itself. I mean, as long as you're going full sensor, you might as well go full sensor. No, this is an absolutely lovely project for people who are way too into their peripherals, which that would be me.
Yeah, how do you do surface finish on the ball though? Thinking about this as like maybe you do like a chocolate covered cherry type of thing where you put the ball on a stick and you dip it in resin and let it like gravity level.
Yeah, it's 3D printed, and then you're going to want it to be really, really round. So you could spend an eternity sanding it, I suppose.
You put it on a lathe and sand it like that.
Put Bondo on it, and then you shave it down so that you don't have to fill in all those ridges, right? Because that would drive me crazy.
Yeah, I was just thinking some kind of, if you did it with epoxy, you could polish it to like a glass finish. Yeah, I'm just making up problems now.
Yeah, you are. That's really awesome, though. I think there must be a good way to make a spherical grinding well, right? And then you just
Ooh,
put really fine grit in there, and you turn it, turn it, turn it.
no, I wrote an article on that.
See?
I went to the Madison Mini Maker Fair a few years ago, and you go around and you see a Raspberry Pi video game, and you see, just the regular projects that you see at a maker fair. And then there was one guy who didn't really have many people around him. He was showing off like stone orbs, and he
Yeah.
actually had the polisher that he built for them there, and like had a whole diorama of the process. And I'm like, why aren't more people paying attention to this? This is the cool thing.
Yeah, see, he's the guy you need right now.
Exactly. All right, we're gonna go in and we're gonna collaborate on this project now.
Exactly. Jacek, meet this guy. All right, my next hack is, well, it's actually secretly another clever power saving hack. Old gas meter gets smart with the ESP8266. Francesco has one of those old style gas meters that has numbers that roll over like an odometer used to on cars if you had a car in the previous century, I guess. What he's done here is stuck a little magnet onto one of the digits, and then he has a Hall effect sensor that he scavenged from a 12-volt computer case fan, puts the Hall sensor where it will get triggered by this magnet as it goes around. He uses that to read out the gas meter and then send that data off to his home automation system. That's a really sweet design, but he doesn't want to go down there and change the batteries all the time. And what I really loved about this, again, is how he managed to get it to use extraordinarily low power. And this one's clever because he takes an ATtiny 13 and pairs that with the ESP8266. So the ESP handles uploading data to the interwebs. I guess it's a server in his own home where he graphs it and stores it in databases and does all that goodness. The ATtiny wakes up every second and reads the Hall effect sensor. And this is clever because the ESP has a fairly large power budget and the ATtiny has, well, basically a tiny one. And it has a really nice, extremely low power sleep mode that it can go into, wake up every second, check if the digits rolled around yet or not, and then go back to sleep. What I love about this is that the ATtiny actually caches a lot of this information. So it updates its count of how many times the little wheel has turned around. And then it only infrequently sends this off to the ESP, which then sends the data off to his house. So it's this like multi-stage design where you use the ATtiny for the fact that it can get by on 5 microamps in sleep mode. And then he uses the ESP for well, naturally, the Wi-Fi. The whole thing works together on 2 AA batteries that he has to change once a year.
Yeah, this is really the perfect use of the AT Tiny, which is an 8-pin microcontroller, because every pin is doing something here. I think the 8th pin is actually connected to a voltage divider and is doing the battery voltage checks, right?
Yeah, so it tells him even when the batteries are going to run out.
Yeah, so he's got the voltage sense on there. He's got the I2C on two of the pins. And then he's got 2 of the pins on the hall sensor, and then that just leaves ground voltage and reset.
I guess sometimes when we put out new microcontroller reviews, people are like, this one does this, but it doesn't do that. And this one does this, but I'll never use it because it doesn't have 4 ADC channels. Or 1 milliamp when it's sleeping. Who could possibly use this device? And the answer is you can. You just have to use something else that sleeps even more efficiently, pair it with it, and then off you go. So I just love the use here of one device that's able to do the ADC, keep track of a counter, and not particularly much else, but then report to the other one. And I think it's sweet. I like to see microcontrollers driving microcontrollers, driving microcontrollers, driving microcontrollers.
I did wonder about the Hall effect sensor. They must have Hall effect sensors that have an interrupt pin.
Yeah, this was one of the things that I thought about this. And I think the AT Tiny has a wake up.
It has an external interrupt into 0. You can do a hardware wake up on a pin.
If he had instead a digital Hall effect sensor, he could absolutely use that for the wake ups.
I think so. He's measuring an analog voltage on the Hall effect.
But I know some of the other Tinies also have an analog comparator that they can use as an interrupt. So yeah, I'd have to go datasheet diving on this. But if he like upgraded to an AT Tiny 2313 or something like that, I mean, he might be able to spend 20 extra cents and get one of the parts that does have an analog comparator that can trigger an interrupt. And then he wouldn't have to have it wake up every second at all. You know, he wouldn't have to buy a fancy Hall effect or anything.
If you use a comparator interrupt, then don't you have like a voltage reference turned on that would kind of kill your low power?
It's not so bad at all. You can use an external voltage reference if you want, and you can make that with, mega ohm resistors because it doesn't have to drive much anyway. So, that's no problem. That's no problem at all. You could totally do it. But I think your solution is the right one, which is to just get a digital Hall effect sensor and use that toggle to wake up the chip.
Well, I think Francesco's solution is the right one because it's already built.
Yeah, right? And he scavenged parts out of a case fan.
Yeah. The beauty of the assembly for this, like the case that the Hall effect sensor is in is sculpted out of hot glue. And it looks like it's molded silicone or something like that. And then it's just very beautifully encased in a black plastic project enclosure. And it's the kind of thing where it's going to last a long time because, it's made for the environment that it's operating in.
Yeah, when the gas inspectors come and they see this magnet taped onto that one wheel, we'll see what happens. But I just love the hack for its simplicity and its elegance, and using the watchdog timer and the AT Tinies to have it run in low power mode is a great old trick. There's a lot you can learn from in this project.
All right, well, let's move along to some bench tools. I was really taken and just smitten by this proof of concept that's already up and doing a great job that Bob Alexander came up with. It's in an article entitled Logic Meter Aims to Make Hobby Electronics Troubleshooting Easier. It kind of looks like a digital multimeter. So it's got a screen, it's got a row of 5 buttons below the screen, and then it's got a dial on the front with a bunch of big labels. But instead of labels like DC, AC, continuity and stuff like that, this has labels like GPS simulator, UART in, UART out, servo, pulse width modulation. And it's kind of a toolkit for you to test out a lot of microcontroller and I guess other common project things. So I was thinking microcontroller because the ability to put out these NEMA words that GPS modules put out lets you test your product as if it was in different parts of the world. So you can actually dial up a world map and navigate to different parts of it, and it'll put out this test data, which is really cool. I don't have a use for that, but I could see how it'd be incredibly useful if you wanted to, location test. Although, hey, it's a good reason to travel around the world. But I thought it was really cool to have this screen. I don't know, it must be about 2.4-inch diagonal screen, and you can have it used as a UART display. So if you have a serial port on your device under test on the bench, you can plug this into it and you can stream out the serial stuff, and it'll do things like automatically detect the baud rate.
Yeah, I love this for what you started off with, which is the thing looks like a multimeter, right? But it's a logic. It's like a bus pirate cross multimeter. It does all these crazy things that you do not expect it to do, but it looks like it's a nice, single purpose, nicely designed piece of equipment. It's really clever. I'm not the only person who thought, I should totally have one of these. If you read through the comments, there are a bunch of people who are like, Tektronix, are you listening? And other such, it's a super clever device. And, maybe you don't have room in your toolkit for a servo tester or, an arbitrary PWM generator or a GPS simulator or any of these stupid things. But once you roll them all together and put them in the same device, it's really kind of cute, and it kind of makes me want one. My favorite label on that front knob is the one that says TBD. What happens there? I would love to find out.
I thought the help button was an interesting label on there as well. I think that the killer thing on here is the user interface, because when you turn, you got the one big physical knob that turns to the different functions, and then you have that row of buttons along the bottom of the screen, which are context buttons. So they get a label on the screen, which really helps you when you only use the function once a year, remember what the heck you're doing. Even in the analysis of it, when Bob is in his video, he just opens it up and he's like, look, anybody building handheld electronic tools could turn this out without breaking a sweat. There's nothing here. Somebody should just build this. And I think that's a really good point.
Yeah, I wonder how long it's going to take for that to get ripped off by some of the Chinese manufacturers. There's that AVR transistor tester that does, transistors, and it does capacitor ESR, and it measures a whole bunch of things. And that was a hobby project. And now you can buy them for $7. They're the yellow ones with the glowing LCD screen and the single button on them. They're a fantastic value because somebody came up with this great hobby project, and then the mass production, high competition Shenzhen electronics market jumped on it, and now you have 3 different manufacturers making it for cheap. I wonder if this will happen with this one.
Yeah, I was thinking the popularity of the nano VNA is really hot right now,
right?
And there are a bunch of those pocket oscilloscopes that have been really hot. I think this fits right along with that. And I mean, you're just talking about a very common microcontroller can do everything that this thing is able to do. I mean, Bob goes through and talks about the DMA modules that are being used for the logic analyzer, which is kind of an interesting discussion. But really, our microcontrollers are going to have all those DMA blocks that you need for them. The screen is nothing special. I mean, it's like the size of a BlackBerry, like the old-timey BlackBerry with the keyboard on it screens. You should definitely be able to find screens that are already out there. It's just really, come up with the case for it that would be the only kind of custom work here.
My first quick hack this week is Serial Studio easily visualizes and logs serial data. Alex Spataru has written a Qt program that basically reads in your data and makes nice graphs out of it. I like this because it's a local solution for something a lot of people turn to the cloud for. And I think the insight that hardware hackers can get from just graphing their data is tremendously useful. So if you don't already have a data visualization system, give this one a look. Next up, upgrading an old MIG welder wire feeder with Arduino. Brett from Theoretically Practical had a really nice but slightly old in-the-tooth welder, and he wanted to bring it up to the modern age. In particular, he wants to get it so that when he pulls the trigger, it sets out a puff of whatever inert gas it's got in it and then starts feeding the wire through. This sounds really trivial, but the upgrade for it costs something like $400 if you can still find one. And so, of course, this is going to be a DIY. And it's not hard to imagine writing a little timing routine for an Arduino that takes care of this, but then also adds in like a spot welding mode and some other features. And so he's just started off on this path, reverse engineering the welder, sticking an Arduino in there. It'll be interesting to see what other new features he can add to it. And last up, this handy tool drains 18 650 cells so you don't have to. I don't know if you know, but if you're going to store your lithium batteries for a long period of time, you should kind of bring them all down to a medium storage voltage. How do you discharge them to about 40% of their capacity? Well, Jasper Sicken has the simplest solution I've ever seen. He takes one of those little USB chargers for lithium that also have a protection circuit in it, and he just uses this protection circuit in line with a whole bunch of big resistors to do the discharging. So what happens is you plug your battery in, it gets pulled down to its minimum, and then the battery protection circuit shuts off the load, and then you can pull it back out and its voltage bounces up to a pretty reasonable storage voltage. I love this because this is just such a simple solution to the problem, using an already existing super cheap battery protection system to do your dirty work.
First up on my list of quick hacks is another great one by Mitsuru Yamada. Now, if you remember Mitsuru Yamada's work, we've been talking about the 6502 computer and other retro computers that are built into aluminum cases for some really awesome industrial design. They were incredibly intricate, but he explained them so well, and now he's boiled down a lot of that knowledge into this one. The article is entitled An Omp Amp from the Ground Up. It's just a little postage stamp size of proto board that has an op amp built out of discrete transistors, a couple of trim pots, and a handful of passives. The great thing is once he builds it, he goes into a bunch of examples and demonstrations of the traits that are going on in there. It's a wonderful learning experience and a fun read. Bill Hurd did a new video this week. Learn Bill Hurd's DIY surface mount assembly process. I really like this one because he's just kind of showing off years and years of hard-won, preferences on the tools and techniques for surface mount reflow. One of the cool things that I liked about it was he shows off a bunch of different grippy tools for vacuum tweezers. He talks a little bit about his process for solder paste stenciling, and then shows off a Black & Decker toaster oven that he has heavily modified and put in, I think it's an open source controller, in order to make it do auto calibration. I don't have one of those yet, but it makes me a little bit jealous. And finally, we have How Does a Circuit Breaker Break? This is a video from the Learn Engineering channel, and it's really good because it has rendered animations that show you what's going on with the coil and the electrical principles during it that make the circuit breaker actually trip. It's a nice kind of wrap your head around the topic subject. Of course, I did want to point into a video that Mike's Electric Stuff did about 4 or 5 years ago, where he spends about 40 minutes going really deep, hands-on, on the workbench about how these breakers work. It's another one of those things that's kind of protecting us, is always around us, and it's nice to appreciate the engineering that went into it. It's now time for our Chemist Articles of the Week. This is a long-form content written by excellent Hackaday authors. Elliot, I think you're first up.
I've got It Costs What? A Sounding into Hearing Aids by Bob Badley, who's actually a product designer with experience in the medical devices industry. But what he's looking at here is kind of what hackers could do with hearing aids to bring the prices down. He starts off with kind of a history of hearing aids, and this goes back to when people used to stick big cones into their ear before electronics. And
the ear horn.
Ear horn.
Ear horn, yeah, you gotta have an ear horn.
Sonny? I can't hear you. Speak into my ear horn. And into the tube era, and then through to kind of the modern transistor era, when hearing aids could be small enough that you don't have to carry them in their own bag along with you. And I guess ends with the ultra modern era, where parts are now so small that you can stick something inside your ear canal that has not just an amplifier and a battery, but also Bluetooth and telephone compatibility and gosh only knows what else. It's really, honestly, they're amazing things, But along with them being amazing comes this incredible price tag. And so they're $1,000, $5,000, $10,000. So the thought experiment here in this article is, if you cut some corners, made some compromises here or there, how cheaply could you make a hearing aid to help people out who just can't afford the super deluxe model? And that's what I thought was interesting here, is him going through kind of the design choices you could make that would end up pushing the price down, or, conversely pushing the price up, I guess.
I like the distinction that he made between hearing aids and PSAPs, which is personal sound amplification products. So I haven't seen a whole lot of television commercials, but one of them that I noticed that was going around there a few years ago was, some like little handheld device that would let you hear things that were going on across the room. And it was obviously meant for people that were having trouble hearing, but weren't for some reason going to an audiologist. That's kind of where the jumping off point for this story was, because there was a device called Low Shade that was claiming to have a bill of materials for less than $1. And, it hangs around your neck where all the smarts and the microphone are, and then just has a set of earbuds that go up into your ears. It's not surprising. I mean, like, the electronic amplification circuitry has been around for so long that it's, cheap as chips at this point. But one of the points that he makes is that you can damage your hearing with those, because they're not necessarily limiting themselves to frequencies that you need help with, and they're not necessarily limiting their volume to something that isn't going to further cause damage.
My father actually has some pretty snazzy hearing aids, and they talk to each other, and so the two of them can do co-DSP and figure out where sounds are coming from, to microphone beam forming around you, and block out background noise from behind you and only listen to the conversation in front of you, and all sorts of crazy fancy stuff that actually is totally irrelevant to what you're saying, because that means they're putting out less volume into his ears and making the stuff that he wants to hear more intelligible. So in addition to kind of bumping up with like an EQ, the parts of the frequency spectrum where a person's hearing's missing, modern ones can do crazy things over on top of that. The question is that too much? Is that what you really need?
It's an interesting question. I mean, when you go to an audiologist and you have a hearing test, they're testing across a large range of spectrum, and then they come back with like a way to quantify the findings. And so I assume that when they're fitting modern hearing aid to a patient, that those are rolled into the algorithms that are doing the correction, which is just fascinating. But the next generations of hearing aids are also allowing the user to like choose different profiles from a smartphone. So you might be able to upload it and say, I'm trying to listen to this particular type of thing. Yeah, the assistive technology is wonderful because it just affects so many people, and I think the real question here is like, how do we make it available for more people? And if you go into the comments, there's a huge comment section. And I think some of the people have kind of overblown their outrage on certain things. But when you look at it, like, yes, this should be boiled down to something that can be afforded by the largest number of people, just because it affects everyone. It's a natural part of aging to lose your hearing, and it kind of isolates you from society. So if we can use technology and then use like economies of scale and other tools of society to make these things available, it's just a huge life changer for everyone. This week I picked an article that Christina Panos wrote called "Machine Learning in the Kitchen Makes for Tasty Mashup Desserts." Elliot, you're going to love this one. I saw this one and I said, we have to talk about it just because Elliot has a deep, deep love of AI, all things AI. But what some people over at Google did was they took a bunch of recipes and they ran them through a machine learning algorithm and had that machine learning algorithm learn what makes a recipe into a bread, into a cake, or into a cookie. And then on the other end of it, with their trained set, they decided, hey, can we make a recipe that comes in at 50% cake and 50% cookie? And then they tried to bake that to see what they got. I like it because it's an interesting look at what you could possibly do with some training sets. I also like this one because it talks about explainability. So you can get an answer out of one of these training sets And then you can kind of look at it and be like, what was the data that led it to make this conclusion? And I think that's an interesting part of it. The great thing is when Christina wrote the article, she also baked these and tried them and said they're delicious.
I was going to say, that's the part I like most out of this, is that Christina makes the half cake, half cookie and says it's marvelous, and makes the half bread, half cookie and says it's kind of crappy. But the fact that she actually did both of them is absolutely lovely. I call BS on the AI here. Yes, I have done a lot of AI in my life. I know its limitations. I'm also old enough that I did it before the modern wave. So I could be wrong here, but the first experiment was 33 recipes. This isn't big data, folks. This isn't like bazillions of recipes so that you can do a 600 layer neural network and, whatever crazy GPT stuff is going on. This is 33 recipes, folks. And then in the second round, they do it with 600 recipes. This is well within the realm of classical statistics. I don't think there's any call to do anything more than like k-means clustering or something like this from like the 70s here. But they did it with no-code machine learning tool. And so, good on them.
Yeah, it's an interesting proof of concept for that. I more look at the potential for this, because what I'd like to see as the next thing is for like allrecipes.com, which has got to have 100,000 recipes or something like that in there, and has a huge user base, to take all the recipes from that and then to like also put in the metadata on like how many people have done it and done a review on it, and like keyword search from the review, like get a huge data set, and then like come up with bastardized recipes that no one would think up from all of these. And I like it that in the comments someone put in the XKCD for this concept, which was saying that like we have to stop inviting the computer science department to our banquets anymore because they keep doing AI recipes that are disgusting.
I want breakies. I really do want to make the half cake, half cookie recipe. I won't lie to you. I think that, the kind of crispiness of a cookie with a cake batter could be actually really delicious.
Well, and if we're not going to get AI inspired recipes, because when you get right down to it, there's a lot of art that goes into baking. Like it's not just numbers. That would be like saying, let's just have the computer compose all the music that we listen to. And there was a whole movement in serialism when they tried it. I hate it. Some people think it's okay, but it didn't end up killing off human composers. I think that in the same way, you're going to have bakers and you're going to have chefs that are doing amazing things. But it would be interesting. It makes me think back to Ben Krasnow's effort to characterize what was going into the cookies. And so he had a rig that would dispense out different proportions of things. He would mix them up one cookie at a time and then bake them to see what happened. I'd like to see, getting away from me needing to do that, I'd like to be able to, take a picture, like measure the height that my cookie rose, and then put the ingredients in and have it tell me like what I needed to change so I didn't get flat cookies.
Yeah, and when you get real AI here, it needs to be able to cook its own cookie recipes, see how it comes out, and adapt going forward. So you can, actually kind of iteratively improve the model and come up with something new. No, I guess I'm surprised that they went for something within the data set. I guess I'm surprised that their examples here were come up with something that's half bread, half cookie. Because you could almost just do that by picking a bread recipe and a cookie recipe and cutting all the ingredients in half. You literally just averaging them. Because they do end up using some yeast, but not much in the bread cookie.
Right.
And they do end up using less butter than you'd use in a cookie, but more butter than you'd use in a cake, in the cakey. I mean...
Well, the problem is the output of the training set. That's the only three things it can tell you is the percentages of cake, cookie, or bread.
Because
and
that's
so all they can
training
do
it
then
on.
is they just play with the different ingredient measurements and then have it look at them, and then it gives them one of those three outputs. So you can't even, it's not even like automatic, like give me a 50% cake, give me a 50% cookie. They just kept themselves adjusting it until it got to that point. So again, it's not this isn't a press button make amazing. It's like a thought experiment on what we could do with these things.
Anyway, kudos to Christina. There's tons of good writing in this one. One of my favorite things is her conclusion about the breakie. I said it to myself going in, and I stand by it after eating these breakies. Yeast does not belong in cookies. So there's that. And I love her stand when they're talking about how they clean the data up, because, neural networks, garbage in, garbage out, right? You have to have these properly classified, and Christina stands up for their choice to put banana bread under cakes instead of cookies.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment in the show notes, which you'll find at hackaday.com/podcast. You can send us an email, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you've baked something cool, let us know about it. tips@hackaday.com. And until next time,
keep on hacking. And
I'm drinking the Midnight Stinger these days.
Just yeah.
All good?
Go.
I got kind of taken to the cleaners on absinthe.
Okay, sorry. Here we go. MIG welder wire feeder.
Oh, is it coffee time yet, man? I'm ready.
Microcontrollers driving microcontrollers.